After you guys make these tables, you guys can graph the mother functions. You guys ready to graph the mother functions? Okay. Don't forget, tangent is y divided by x. Cotangent is x divided by y. And so at each of these angles on the unit circle, I just use the x and the y to find those values. Yeah? Yeah. And hopefully you guys think enough to see the patterns. There's patterns going on here.
I think all the time.
You think all the time? I don't know if that's true. I think all the time. Okay, I can do tangent x.
I think about my less mistakes.
Okay, let's graph. Let's graph, shall we? We shall.
Okay.
Now, you can graph the parent functions differently than what I'm about to do, but I'm just going to keep it like what we've been doing, like the standard, which is 0 to 2 pi. Okay, and then right in the middle of that would be pi, right? And then right in the middle of that would be pi over 2. And then right in the middle of the pi and the 2 pi. What would that be right in the middle of pi and 2 pi? That would be 3 pi over 2. Okay, so how does our graph look for tangent? When we're at 0, we're at 0. Okay, so I put a dot right here. Okay, when we're at pi over 6, let's skip you. Let's do pi over 4. Where's pi over 4? Pi over 4 isn't pi over 4 between, like right in the middle of 0 and pi over 2? It is, isn't it? So at pi over 4, we get uno. So I'm going to put uno right there. Let's go ahead and throw our negative uno on our y-axis. Okay, so we got, oh yeah, that's what I wanted to do. I wanted to scratch out these guys because I don't care about them. I mean, who knows what rad 3 is anyways? They're on our graph, but we only need certain points to graph the mother function. And the ones with the 0, the DNEs, and the 1s is all we pretty much need. What do we get when we go to pi over 2? DNE. DNE. Okay, so we have an asymptote right there. Okay. And then we have the point between pi over 2 and pi. What is that? 3 pi over 2. That is negative uno. And so I'm going to put a dot right there. At pi, I put a dot at 0, so I put a dot right there. And then we jump up to 5 pi over 4, which is right between pi and 3 pi over 2, so that's right there. We're going to put a dot right up there at 1. And then finally, when we get to 3 pi over 2, what happens? DNE. Okay, almost done with our parent function here. Our mother function. All right, and then we have the point that's between 3 pi over 2 and 2 pi, which is 7 pi over 4. We get negative 1, so I put a dot right there. And then at 2 pi, we get 0. So how does our function look? Ooh. Okay, the arrows at the ends are still attracted to the asymptotes, just like the rational functions that you guys learned about, and just like the logarithmic functions that you learned about. But there's something different about this trigonometric function than sine and cosine. When does this function start repeating himself?
Never.
Like what's the length of the period?
Never.
What is the length from here to here? Because doesn't he start repeating himself? Like this is going to go like this, and then we're going to have another one like this, and we're going to have another one like it just keeps repeating itself. What's the distance right here? It's pi. The period of the mother function for tangent is path. Now, if you don't believe me about it going up forever and ever, just pick a number right here that's between whatever this number is. That's 5 pi over 4. Pick a number that's between 5 pi over 4 and 3 pi over 2, and you'll start getting numbers that go up here, and they get even closer. It'll be like way up here, and so on and so forth. But anyways, that is tangent. But what does cotangent look like? Ooh, what does cotangent look like? Tangent looks exactly like tangent, except the asymptotes are a little different, and the lines don't go up, they go down. You see, these ones go up. They go from left to right, they go up, right? Left to right, they go up. Okay, these ones are going to go down for cotangent. Okay, so that's the switch. And then look at the DNEs. Tangent doesn't exist at pi over 2, but cotangent doesn't exist at 0. In some ways, I think cotangent is actually a little easier to graph than tangent because we start with the asymptotes. And guys, there's other ways to think about this, but anyways, I'm showing you one way. All right, so this is 0. This is going to be 2 pi. Right in the middle, I'm going to put my pi. And right in the middle of that, I'm going to put pi over 2. And then right in the middle of that, I'm going to put, what's in the middle of that? 3 pi over 2. Okay, so, and then we have our other points, like right in the middle of those. We're going to probably need those. Those are the pi over 4 points. Okay, so at 0, we're not existing. So I'm going to put an asymptote right there. And then our next one is pi over 4. We're at 1. Now. Okay, so I'm going to put a point up here at 1. Let's make that 1. There's now right there. And then at pi over 2, what do we get? What do we get? 0. All right, 0. Then our next point at 3 pi over 4, we're going to go down to -1. Let's make that -1 right there. So I'm going to go bam, -1. And then what happens at pi? At pi, we get does not exist. Okay, and then we have, after pi, we have 5 pi over 4. That one's now. And so I'm going to put a dot right there. And then we're going to get 0. And then we're going to get a -1. And then we're going to get another asymptote.
How do you make that sound?
Okay, so I'm connecting my dots.
Just don't answer his question.
Okay. Yeah, I'm not going to answer your question. That's cotangent. But you guys see the difference?
Yes.
Very similar,
Yes.
but slightly different. Okay, now whenever you graph or tangent or cotangent, just like our other functions, you need 1, 2, 3, 4, 5 points. Okay, it goes 1, 2, 3, 4. Okay, you need 5 of them. Okay, you normally would have your asymptotes on the ends, and then you have the midpoint, and then you have your satellites, so you get your shape. Okay, but anyways, we're gonna use the general shape of the mother function to graph our other guys. Let's do it.